you want to fare well, you need to know that parallel lines, they never touch. They're always the same distance apart. It's as if they don't like each other much, and there's only one thing that comes between them. Yes, a line that passes right through each of them. It's called the transversal, and it has several angle properties, just like these. Vertically opposite angles are equal, corresponding angles are equal, alternate interior angles are equal, co-interior angles equal 180. Vertically opposite angles are equal, corresponding angles are equal, alternate interior angles are equal, co-interior angles equal 180.
Welcome back, geometry students. Here we are at 3.2 in Big Ideas, looking at parallel lines and transversals. So we looked yesterday at what transversals were. Today we're going to look at transversal. It's going to go through two parallel lines and the different properties that they're going to make. We know that when they do go through two lines, we talked about the kind of types of angle relationships it makes with like alternate interior and exteriors, corresponding angles. Those kind, but now they're going to actually have specific properties with those. So that's what we're going to be looking at today in this lesson. Before we get to that, let's go ahead and do a little cartoon. So here's a geometry cartoon. It feels like 90 degrees out here. It says a 90-degree triangle. It feels like 360 degrees to me, says the circle. And obviously he's sweating a whole lot more with 360 degrees. 90s, it's not too bad. All right, well, let's get into our lesson here. All right, so on page 73, we see our theorems here, and there are 4 of them, one for each different type of angle. So we talked about these types of angles yesterday, what these form here: corresponding angles, alternate interior, alternate exterior, and consecutive interior angles. That's when you have transversal going through two lines. You form those angles, those angle relationships. But now what we're going to see is there special properties if the lines that this transversal goes through are parallel lines. As you can see on our diagram right here, those little parallel marked with those little red arrows show us on the diagram that these two lines, P and Q, are parallel to each other. So that's what's now going to say here for corresponding angles. If two lines are parallel, or if two parallel lines are cut by a transversal, if you have that situation, which is we have here on this diagram, then we can conclude some things about these relationships. So our corresponding angles, remember, corresponding are the ones that are on the same corner but different intersections. These are like two intersections out on the streets, and 1 and 5 is the same corner but different intersections. 2 and 6 are corresponding. 3, 7, 4, 8. Those are your corresponding. There's 4 pairs of those on this one. And so what we can say here is the corresponding angles are always congruent. So I want to highlight that part right there, or underline that part there. And here's an example. It just shows you, here's 2 of them, 2 and 6, 3 and 7. Those are congruent, but we also can say that 4 and 8 are congruent as well. We could say 1 and 5 are congruent also. Number 3.2, now talking about the alternate interior. So again, it starts off the same. If two parallel lines are cut by a transversal, if we have that situation like we do here, then we can conclude that the alternate interior angles are congruent. Those are also congruent. Alternate interior angles are congruent. So example for those ones, they're alternate. They're on different sides. One's on the left, one's on the right of this transversal line, this T. And they're also on the inside, so they're in between here. So we're looking at 3 and 4, 5 and 6. These are the inside numbers. So 3 with 6 are alternate, and 4 and 5 are alternate interior angles. So those are congruent. 3 and 6 are congruent, 4 and 5 are congruent. That's what it says there. There's only 2 pairs of those. That's all we could even say for that one. Alternate exterior angles, same situation. If you have 2 parallel lines cut by the transversal here, then alternate exterior angles are congruent as well. So these are all showing that these are all going to be congruent. So we're talking about the again, alternate, one on the left, one on the right of this transversal line, and they're on the outside. So we're talking about 1 and 2 and 7 and 8. So 1 and 8 are alternate exterior. Those are congruent. 2 and 7 are also going to be ones that are congruent there for alternate exteriors. These are things we can conclude. So far, every single one here has been congruent. There's 3 of them are congruent. This consecutive interior, we're going to see, are not congruent. So if we have the same situation, 2 parallel lines cut by the transversal, this situation here, if we are consecutive interior, now interior, again, we go back inside with 3 and 4, 5, and 6. Consecutive means they're on the same side. So that means 3 and 5, 4 and 6. So these are not congruent. 3 is not congruent with 5. You can see that 3 is a different angle than 5. 5, it looks like obtuse. 3 looks acute. So those are definitely not congruent. 4 and 6 are not congruent, but they're consecutive interior. What we can conclude about those, it says then, the pairs of consecutive interior angles are supplementary. That means they're going to add up to 180. So 3 and 5, 3 plus 5 are going to add up to 180. It says 3 and 5 are supplementary. 4 and 6 are also supplementary. So we're noticing that some of them are going to be, or most of them here, 3 of them are congruent. 1 is going to be supplementary, adding up to 180. Now I want you to also write down here on this paper, just somewhere, maybe up above, we have vertical angles right there on your vocabulary right up there. Let's put that there. So above the theorems on 73, you have vertical angles, and we know vertical angles here are always congruent. So vertical angles are congruent. You want to say that there for vertical angles. You can just write they are congruent. So on this diagram here that we're looking at, the vertical angles, we can give an example for those. We could say 1 and 4. Those are vertical angles. They're congruent to each other. So we could also say 2 and 3 are congruent because of vertical angles. We could say 5 and 8 are congruent because of vertical angles, and 6 and 7 are also congruent because of the vertical angles. There's 4 pairs of vertical angles here that would be congruent. But this is just one example. You might want to write down all the pairs of vertical angles as well. Now there's one more that's not on your vocabulary. Let's maybe put that maybe right below the vertical angles, right above that theorems that's in bold there. You can say linear pair is another one. Linear pair are supplementary. We see some linear pairs in our diagram as well. So linear pairs when you have 2 angles that are adjacent angles and there are supplementary angles. So there's 1 and 2 as an example of that. We can see there's different angles. 1 plus 2 are going to equal 180. These are a linear pair. They are going to add up to 180. 3 and 4 is also an example of a linear pair. They would add up to 180. They're supplementary. 5 and 6 are supplementary. 7 and 8 are a linear pair, supplementary because of a linear pair. So here's some other angle relationships we see in the same diagram. So really 6 of them that you're going to need to really know from this one diagram where the 2 parallel lines are cutting the transversal. And you see they're either going to be congruent or they're going to be supplementary. So the congruent ones here are the corresponding, the alternate interior and alternate exterior, and the vertical. Those are all congruent. The supplementary ones are the consecutive interior and the linear pair. Those are the supplementary ones. They're adding up to 180. All right, so let's move on from here to look at our... Okay, so here we are at the extra practice. 1 through 4. It says on page 74. In fact, number 4 is actually on the top of 75. But it says here, find the measure of measure of 1 and the measure of 2. So measure of angle 1, measure of angle 2. Tell which theorem you use in each case. So we're going to find the angle measure and then also give a reason for that. Which theorem did we use to figure that out? And that would be one of those 6 theorems, really. We got the linear pair, the corresponding, the vertical, the alternate interior and exterior ones, all those ones we just talked about. So on number 1, and I'll do number 1 and then I'll give you a chance to try 2, 3, and 4 after that. So I'll show you 1 together and then you'll pause the video for 2, 3, and 4 and try those on your own. But if we look at number 1 here, this one is 110 degrees. Is there a relationship between angle 1 and this 110 degrees? And there is. Right there. We know that those 2 are alternate interior. They're on the inside. These are interior ones and these 2 are interior as well. And they're on opposite sides of the transversal. So they're alternate interiors. So we know those are congruent. So that we can say right off the bat that the measure of angle 1, or angle 1 is 110 degrees because of alternate interior. I'm abbreviating here, of course. You can abbreviate on yours too, or you can write the whole thing out. Then we can say, okay, for 2, does 2 have a relationship either with 110, or now that we know that 1 is 110, does it have a relationship there? So we could say more than one way here, but if we wanted to just go off of the corresponding, because 2 is corresponding also with 110 degrees, and corresponding angles are always congruent. And so we could do that because angle 2 is 110 degrees because of corresponding angles. We could also say that's 110 degrees now because of 1, because of vertical angles. These are vertical angles, so they're also congruent. So we could have used vertical angles to explain that as well. All right, so go ahead and pause the video. Do the same thing for 2, 3, 4. Identify the angle measure in degrees, and then write down which theorem you used to figure that out. And then go ahead and play it, and we'll catch up in a minute and check our answers. All right, so hopefully you did number 2, 3, and 4. Now you're just going to check your answers to see if you are correct on this. So let's see, number 1, does number 1 have a relationship with the 63 degrees? It's there. And it does. It is in the corresponding, same corner, different intersections. So there's our 2 intersections here. 63 and 1 are on the same corner. Corresponding positions are congruent. So we could say for that one, corresponding positions are congruent. I think I may have done 3 next. Yes, I did. So let me do 3. Actually, I'm going to come back to 2. I went that way. Let's look at 3 first, and then we'll come back to 2. So number 1 here does have a relationship with 95 degrees. It's in the vertical angles position, and those are always congruent. So we can say that, yeah, imaginary angle 1 is 95 degrees because of vertical angles. And then looking at 2, does 2 have a relationship with 95? And it's in the corresponding position, same corner, the different intersections. So that's also congruent. 95 is congruent there because of corresponding. And again, I'm just abbreviating here. So now coming back to 2, we said this was corresponding on this one. So it's 63 degrees because of the corresponding positions are always congruent. And then number 2, does that have a relationship with 63 degrees? And it does. It's the consecutive interior angles. So those are supplementary. So how do we figure that out? It's not, 2 is not 63 degrees. 2 would be supplementary to 63 degrees. So this is going to take a little bit of a subtraction problem. So it's like 180. If you take your 180 degrees, subtract 63, and you find it's 117. Because 117 plus 63 would add up to 180. So it's got to be, number 2 is going to be 117 degrees because of consecutive interior angles. You could have also used linear pair as well in this one, because since you know 1 is 63, this linear pair is the same thing, supplementary there. And then coming over to 4, does 1 have a relationship with the 101 degrees? And it does. It's in the vertical angle position right there, which are congruent. So you can say 1 is 110 degrees because of vertical angles. I just put vert for vertical. Again, I'm just abbreviating. And then does 2 have a relationship with the 110 degrees? And it does. It's in the corresponding position right there. So those are also congruent, corresponding or congruent. So 2 is also going to be 101 degrees. We could have also used the 1 on this one with alternate interior angles, because 1 and 2 are in alternate interior angle positions. And once we found 1, we could have found 2 from that as well. All right, let's go on to our joke of the day right now. So our joke of the day says, what do you call a dinosaur with an extensive vocabulary? What do you call a dinosaur with an extensive vocabulary? Well, you would call him a thesaurus, of course. A thesaurus. Not sure what that would look like in a dinosaur, but maybe a dinosaur with glasses, perhaps. Okay, so page 75 has the rest of the extra practice, 5 through 8. It says here, just find the value of x. So we're going to need to be setting up some equations using what we know from before with what is congruent and what is supplementary from our relationships here. We have our 2 parallel lines. You can see on all the diagrams here, you got your 2 parallel lines with those parallel marks there. This would be your transversal. It's cutting it through, giving you the 2 intersections, and those 2 intersections all have those angle relationships that we now know are either going to be congruent or supplementary, and we'll just use that to set up an equation to solve for x. So we want to see, okay, does this x plus 2 have a relationship with the 110? And it does. In fact, they're on opposite sides of the transversal, so they're alternate, and they're also on the outside, which are exterior. So they're alternate exterior angles, which are always congruent. So we could say that this equals 110. The x plus 12 is equal to 110. So we'll set up that equation like that. X plus 12 equals to 110. And just subtract 12 from both sides to find x. So x is equal to 98. There it is. It's that quick. Now with number 7, actually, number 6 is right, but I'm doing it again. I'm going to do number 7 next, then we'll come back to 6. So number 7, let's go to here, is showing us that we have a 4x here degrees, we have a 52 degrees here, and then this is just 6. This is just, they just numbered this angle and gave it a number. This is number 6, or angle 6. That's not 6 degrees, that's nothing really, it's just given a number. So we're probably going to have to figure out what that is to help us set up our equation. Because as you notice, the 4x degrees and the 52 degrees, they don't have any relationship. You know, they're exterior, but they're on the same side, so that's not a relationship there. So what we would want to see is, okay, then 6, does 6 have a relationship with either one of these? Really, the 52 degrees is what it does. Does 6 have a relationship with the 52 degrees? And it does. They're different intersections, but they're the same corner. So that's the corresponding positions. So that tells me that 6 is congruent to 52 degrees. 6 is 52 degrees. So we can conclude that. And now we know that these two are a linear pair. 4x degrees and this 52 is now a linear pair. So now we can just set up our equation where we're going to add these together and it's going to equal 180. So 4x plus 52 is equal to 180. And then we just want to solve for x. So we're going to subtract 52 from both sides. And here we're going to have to maybe borrow here from 18, make that into, or borrow from 8, I should say, make that a 7, make this 0 into a 10. And so that's going to be 10 minus 2, this is 8, and basically 17 minus 5 there. So it's 128 now. 4x is equal to 128. Divide by 4. And so when we do the 128 divided by 4, we can say, well, 12 divided by 4 is 3, and this is 2. So 32 is what that should be. X is equal to 32. All right, so now that you saw me do these two, 5 and 7, I want you to try 6 and 8 on your own and then see if you can get the answer for X, and then play the video and check your answers. So go ahead and pause the video now and do 6 and 8. All right, so you should have completed 6 and 8, and you're just checking out if you set up your equation right and you solved it correctly. So number 6 is kind of like 5. Does the x plus, or the 10x minus 55 here, does that have a relationship with 45 degrees? And the answer is yes. It has their inside and their alternate. So alternate interior angles, and those are always congruent. So we could say those are going to equal each other. So I'll set up our equation as the 10x minus 55 is equal to 45. And now we just add 55 to both sides. So 10x is equal to 100. Divide by 10. And so x is equal to 10. So there's our answer for 6. And then for number 8, we have this angle 2 right here, which we're probably going to need to know. Does that have a relationship with the 150 degrees? Because 153 degrees does not have any relationship with this 2x minus 3. So we're going to need to figure out what is 2 here. How many degrees is the angle 2? And so the relationship here is the consecutive interior. They're on the inside and they're on the same side. So that means they're supplementary. So they add up to 180. So we can do a little quick subtraction problem. 180 minus 153 is 27. So that tells us that 27 plus the 153 is adding up to 180. So number 2 is 27 degrees. And so now the relationship between 2 and this 2x minus 3 are their vertical angles right there. So the vertical angles are always congruent. So now we can set up our equation as 2x minus 3 is equal to 27. And here we'll just add 3 to both sides, getting us 30. So 2x is equal to 30. Divide by 2. And so x is equal to 15. And so there's our answer for x on that one. All right, so that concludes our lesson here on 3.2. You want to continue on with the assignment, and then I'll see you on the next lesson.